Now we'd like to demonstrate one of the most infamous exploits of the past year. We're going to demonstrate Spectre, which is related to the Meltdown exploit, and taken together these two exploits are perhaps the most pervasive exploits on modern-day processors. These exploits affect about 23 years worth, that's going all the way back to 1995, of Intel processors with a few minor exceptions. Similar exploits may also affect AMD, ARM, and other architectures because they take advantage of something called speculative execution. A processor that uses speculative execution speculates and tries to load into memory data which may be useful next. Meltdown is able to grab all of the memory on a system, and Spectre is able to remove the traditional memory sandboxing between applications on a system. By that I mean, if you're on a system running a program, you're able to pull from memory information that another program is using and that you should never have access to. To demonstrate this, we have in the center a virtual machine which is vulnerable to these two exploits. And we're going to enter information into a web form that's running on this virtual machine. So you can think of this VM as, for example, a cloud server that's running somewhere with a web form. And we're just an ordinary user. You can see this user right here. This user is going to be able to, at the end of the demonstration, pull from memory the information entered into that web form, which was not supposed to be accessed. First, we want to make sure that we're actually on a machine that is vulnerable to Spectre and Meltdown. So we're going to run what is now the industry standard script to check the system. So you'll see here all of the information about the Linux kernel and the processor, and then you have the three vulnerabilities, the two variants of Spectre and the one variant of Meltdown, and you'll see vulnerable, vulnerable, vulnerable. Okay. Now in this browser window, I have a web application which again is running on the virtual machine. It's being hosted there and served up through the web browser. And I'm going to pop a secret into this form. Now this is saved to disk and then loaded into memory. And then, you know what, why don't I do something that's a little more interesting than just typing secret? Why don't I try handsome Dan is awesome? And that's Yale's awesome bulldog mascot. All right, so now that that phrase is there, I'm going to go into my directory where I have my proof of concept. And this proof of concept is based on one of the standard proof of concepts of Spectre that's out there. We've modified the code a little bit, and we're going to have all of that up on GitHub. So if you'd like to double check our work and make sure that we're actually pulling, for example, this phrase from memory, you can do so. Okay, now we're going to run the exploit. And you'll see right here in this middle column, it says handsome Dan is awesome, and we've grabbed it character by character from memory. Now in this case, of course, it's not that big of a deal, but that could be a username or a password on any web application that's running on that server. And I could just be an ordinary user or an ordinary program running on that server that's not supposed to have access to such sensitive information.